Hello everyone. Let us see next example of ordinary differential equation. That is dy by dx is equal to y upon x minus under root of x into y. First of all, we have to decide whether this example is of dy by dx form or dx by dy form. If dy both, because in this particular example both y and x terms are there, okay. But if you observe this RHS side, you cannot divide this term y upon x because numerator contains of only one term, okay. Denominator contains two terms. That's why, for that reason, this is an example for dx by dy. So that reverse the term, we get both side dx upon dy is equal to x minus root of xy upon y. Now we can divide this term, x upon y minus root xy upon y. Again one root get cancelled from this y, dx by dy becomes x upon y minus root x upon root y. Now this is a linear form of dx by dy. That's why x term should be on the LHS side. Which term contains x? This contains x. That's why this term should be on should be on LHS side. It becomes dx by dy minus x upon y is equal to this total RHS as it is. Okay. Now if you observe this equation, this is x, and rest of the term should be of function of y, right? This 1 upon y is okay, but this RHS side must contain function of y only. It should not contain x. That's why we have to divide this whole equation by this term root x. Okay. Now next step will be divide this term by root x, because we don't want the function of x term on RHS side, because this is a dx upon dy form. What is dx upon dy form? Of linear dx by dy plus px is equal to q, where p and q are functions of y only, right? We don't want function of x on RHS side in this particular reverse type of linear differential equation. That's why this x is okay, but on RHS side there should not be x. That's why divide this total term by this function, this term root x in the next step. Therefore divide by root x, equation number, call that equation number 1. Given equation, we get 1 upon root x dx by dy minus dividing root x 1 root x cancel from this x, we get in the numerator root x upon y as it is, minus root x get cancelled from RHS side. This becomes equation number, call that equation number okay, call this equation number, we don't need now this equation, call this equation as number 1. We have to solve this equation. Now again we know this root x derivative is 1 upon 2 root x. This is 1 upon root x is there. 2 we can adjust. That's why what is our substitution? The coefficient of this y is root x. Put root x is equal to v. Now differentiate with respect to obviously this y. What we get? Root x derivative is 1 upon 2 root x. X derivative dx by dy with respect to y is equal to v derivative is dv by dy. Now take 2 on that side. We get 1 upon root x. This dx by dy becomes 2 dv by dy. Put these values in given equation. What we get? Equation 1 becomes 2 dv by dy minus this root x is v upon y is equal to RHS side doesn't change because we are putting root x value. That's why we have to keep RHS side as it is. Now this is a linear equation, but for that the coefficient of this term should be 1. That's why divide this total term by 2. We get dv by dy minus v upon 2y is equal to minus 1 upon 2 root y, which is the linear equation. Instead of y there is only v in this particular linear equation, and instead of x there is y. That's why p is equal to coefficient of this v with minus sign, that is 1 upon 2y, and q is total RHS side. Now integrating factor as per our solution of linear differential equation. This is of the dy by dx plus py is equal to q, right? Therefore, by comparing this p and q, we get this integrating factor is equal to e raised to integration of p dy. Put this value of p here, take minus 1 upon 2 outside, 1 upon y integration is with respect to y is log y. Now take that minus half on the indice of this y by log property. We get e raised to log of y raised to minus half. Now we know e into e raised to log becomes identity function. We and log gets cancelled. Answer is only y raised to minus half. And minus half is 1 upon root y. Take minus on the denominator. And half is a root. Now solution is instead of y there is v, instead of x there is y. That's why solution becomes v into integrating factor is equal to integration of q into integrating factor, instead of dx that is dy plus c. Now put these values here, we get v into 1 upon root y integrating factor is equal to q is this, into integrating factor is this, into dy plus c. Now root y becomes y, and 1 minus half comes outside. 1 upon y is log y. Integration of 1 by y is log y. Now again resubstitute v, because v is not our a variable. It is not in the example. Example contains only x and y. Okay, therefore put v, resubstitute v as root x. Therefore root x upon y, root y is equal to minus half log y plus c is our solution. Now next example, tan y into dy by dx plus tan x is equal to cos y cos square x. Now if you observe this is a dy by dx linear form, okay, but here on RHS side if you observe, on RHS side only the function of x we have there, we have to adjust. That's why we don't need this cos y. That's why first step will be divide this term by cos y. Therefore it becomes tan y upon cos y dy by dx plus tan x upon cos y is equal to cos square x. Now it consists of trigonometry, that's why we have to simplify this. Tan y is sine upon cos, and cos is 1 upon sec. That's why it comes to the numerator, dy by dx plus again tan x into 1 upon cos is sec is equal to as it is cos square x. Now we know sine upon cos is tan and sec y, and here sec y is there, and we know sec y derivative is sec x tan x. That's why we are doing all this adjustments. Now rest of the terms as it is, call that equation number 1. And sec y, we have to put sec y is equal to v. Now take differentiate with respect to x, we get sec x derivative sec x tan x, sec y tan y, y derivative is dy by dx is equal to v derivative is dv by dx. Now put these values in our given equation. What we get, this term becomes dv by dx plus tan x as it is. This term becomes v is equal to cos square x, which is a linear differential equation. Instead of y there is only v and x as it is, which is a homework for you. This is your p, this is your q, and solve the equation. Okay, find the integrating factor, and this is the answer. Sec y is equal to sin x plus c is the answer. This is the homework for you. Now let us see next. Dy by dx plus y tan x minus y square sec x. Now if you see on RHS side, this is on LHS side dy by dx term is there, and that's why y term should be there. Out of these two terms, this term contains only y. That's why this term we have to take it on LHS side. It becomes dy by dx minus y tan x is equal to minus y square sec x. Now if you observe RHS side, on RHS side we want only function of x. We don't need this y square or minus y square. That's why we have to divide this total term by y square. Therefore it becomes 1 upon y square dy by dx minus 1y gets cancelled, 1 upon y tan x as it is minus is equal to minus y square gets cancelled, and only sec x. Now if you observe this thing, 1 upon y derivative, 1 upon x derivative is minus 1 upon x square. Only variables should be adjusted. Constants we can adjust at any step. That's why the next step will be putting 1 upon y is equal to v. Now differentiate this equation with respect to x. What we get? 1 upon y derivative is minus 1 upon y square. Y derivative is dy by dx is equal to v derivative is dv by dx. Now we don't need this minus. Take this minus on RHS side. Now put these values here. We get what we get. It becomes dv by dx. Okay. And 1 upon y becomes, this is minus dv by dx, minus 1 upon y becomes v, this tan x as it is, and minus sec x as it is. Okay, multiply both the side by minus, we get dv by dx plus v tan x is equal to sec x. This is a linear. Okay, this is p, this is q. Solve by using our regular formula, integrating factor and solution. Instead of y there is v, therefore at the last the answer should be in x and y. We have to resubstitute as usual v. Okay, this is the answer. Sec x upon y is equal to tan x plus c is the answer for this particular example. Okay, let us see now next. E raised to y into bracket 1 plus dy by dx is equal to e raised to x. Okay, now first take this e raised to y inside to this bracket. We get e raised to y plus e raised to y into dy by dx is equal to e raised to x. Take this e raised to y, reverse this term, we get e raised to y dy by dx plus e raised to y is equal to e raised to x. Okay, if you observe this, we will get e raised to x derivative is e raised to x present here. That's why call this equation number 1. Now we have to substitute e raised to y as v. Therefore differentiate with respect to x on both sides. E raised to y derivative is e raised to y derivative is dy by dx. This is chain rule. Is equal to v derivative is v dv by dx. Put this value in a given equation, we get this is dv by dx plus e raised to y is only v is equal to e raised to x on RHS side as it is, which is a straightforward linear, simple linear equation, linear differential equation. Instead of y there is v, p value is coefficient of v, that is 1, q value is RHS side e raised to x. Okay, this is again a homework for you. Answer is this, e raised to x into e raised to y, that is e raised to x plus y is equal to e raised to 2x by 2 plus c. Next, x cube y square plus xy into dx is equal to dy. Okay, if you observe this total term, there is again x. If you divide this total term by dy, you have to take this bracket on this side and it comes to the denominator, which is can't be we can solve. That's why we have to take this dx on that side. That's why divide this total term by dx, we get x cube dy by dx is equal to x cube y square plus xy. Okay, first step. Now next step, y term should be on LHS side. Out of these two term which contain y term, this term contain y term. That's why we have to take this term on LHS side. Divide dx, this term becomes minus xy is equal to x cube y square. Okay, second step complete. Now if you observe this dy by dx means we have to, this y should be present here and rest of all terms contains only x. Okay, this term contains x, that is okay, but on our RHS side x for the RHS contain only x. That's why we don't need this y square on RHS side. That's why the next step will be divide this total term by y square. We get 1 upon y square dy by dx minus 1y gets cancelled, x upon y is equal to, on RHS side it becomes now q, that is x cube. Okay, now this is a substitution we have to decide. X coefficient is 1 by y. 1 by y derivative is 1 as 1 by y square is present here. That's why what is our substitution? 1 upon y. You can put minus also, doesn't matter. Okay, put 1 upon y is equal to v. Differentiate with respect to x. What we get? 1 upon y derivative is minus 1 by y square. Dy by y derivative is dy by dx is equal to dv by dx. Now take minus on that side, we get 1 upon y square dy by dx is equal to minus dv by dx. Put these values here in this equation. Equation number 1 becomes minus dv by dx minus this x as it is 1 by y becomes v is equal to RHS side as it is x cube. Okay, multiply throughout by minus to make this coefficient 1. Therefore, it becomes dv by dx plus xv is equal to minus x cube, which is a linear differential equation. Instead of y, there is only v. This is p, this is q. Okay, and therefore, let us solve this. Okay, let us solve this equation because integration is different. P is equal to x, q is equal to RHS side minus x cube. Now integrating factor is e raised to p dx, which is equal to e raised to p is x dx, x integration is x square by 2. Therefore, solution is instead of y there is v. V into integrating factor is equal to integration of q into integrating factor into dx plus c. Put this integrating factor here, we get v into e raised to x square by 2 is equal to integration of q, that is minus x cube, and integrating factor e raised to x square by 2 dx. Take minus outside, integration of x cube e raised to x square by 2 dx. Now this is a straightforward. You can use u into v rule also here, okay, or substitution method also. Okay, we are using substitution method, and u by v rule you can use, but it becomes complicated because exponential term contains fraction. That's why it is very easy to use substitution method here. Now whatever the index of exponential, we have to put that t. This is a substitution. Now take put x square by 2 is equal to, in such a type of example where arithmetic is there into exponential raised to some arithmetic, we have to put that function as t. Okay, in the most of the example, x square by 2 is equal to t. Now take derivative on both sides. X square derivative is 2x, 2 is a constant as it is, dx is equal to t derivative is dt. To 2 gets cancelled, x dx becomes dt. Therefore our equation becomes, they call that equation number 2. This minus as it is, so split this x cube as x square into x, because we need this x dx. Okay, it becomes this x into x square, this x cube e raised to as it is dx plus c. Now x square by 2 is t, from that x square becomes 2t. Okay, therefore put x square as 2t, x dx as dt, and e raised to again this term is t. Okay, this substitution over plus c. Now take my 2 outside, and t into e raised to t, we can use u into v rule, u into integration of e raised to t, second term minus t derivative is 1, e raised to t integration is e raised to t. Next term will be plus 1 derivative is 0. That's why u into v rule stops here, plus c as it is. Now take e raised to t common, and bracket contain t minus 1 only. Now resubstitute t and v. Okay, because our example contain only x and y. Therefore e raised to again t becomes x square by 2. Here also x square by 2 minus 1 plus c. Now again resubstitute v as this in last page, 1 upon y. We have v, this is our substitution for this example. Therefore resubstitute v also here. It becomes e raised to x square by 2 upon this y is equal to minus 2 e raised to take minus 2 out inside this bracket, we get e raised to x square by 2 minus this become plus 2 minus this 2 gets cancelled, x square plus c as it is. Okay, now let us see next example. X into y into bracket 1 plus xy square dy by dx is equal to 1. Okay, now if you put this dy by dx as it is, then we have to take this coefficient on RHS side, which is comes to the denominator, which is becomes more complicated. That's why we have to take this dy by dx on RHS side. It becomes dx upon dy is equal to this total term as it is. Take this x into y inside, we get xy plus x square y cube as it is. Okay, if you see, observe this equation, dx upon dy means on LHS side we need x term, and apart from these two term x term is present here. That's why you were to take this term on LHS side. It becomes dx by dy minus xy is equal to this total term. Okay. Now we want this x here, this x here, and rest of the all functions should be of y. This is function of y. This is okay. But on RHS side, we don't need this x square because we want y function on RHS side. Therefore, next step will be you have to divide this equation by x square. Therefore, divide by x square, what we get? 1 upon x square dxy dy is equal to 1x gets cancelled, y upon this 1x remains is equal to y cube. Call that equation number 1. Now, if you observe this coefficient of this y is 1 upon x, derivative is minus 1 by x square. That's why our substitution will be 1 upon x is equal to v. Differentiate with respect to y. We have to differentiate with respect to that variable which present in the denominator in the given equation. Okay. Therefore, differentiate the given equation with respect to y. 1 upon x derivative is minus 1 by x square. X derivative should be multiplied with respect to y is dx by dy is equal to v derivatives with respect to y dv by dy. Take minus on that side, we get 1 upon x square dx by dy becomes minus, put these values here, minus dv by dy minus, as it is, 1 upon x is v into y, or y into v is equal to y cube as it is. Multiply throughout by minus, we get dv by dy plus y into v is equal to minus y cube, which is a linear differential equation. Instead of y, there is v. Instead of x, there is y. This is your p. This is p. This is q. Okay. This is a homework again for you. Instead of x, remember that there is a y. Instead of y, there is v. That's why accordingly change. You have to make change in the given formula. This is the solution. 1 upon x is equal to 2 minus y square plus c into e raised to minus y square by 2. Okay. Your answer can be different, little bit different, because c into means they have combined the log terms. You can keep that as it is, doesn't matter. Okay. Okay. These are the some exact we have till now we have studied the exact differential equation and the reducible examples depend on the substitution. Reducible exact differential equation. Before that, we have seen linear differential equation and its solution. And after that, we have seen the examples of Bernoulli equations. That means reducible linear differential equations. Okay, these 2 points, 4 points we have covered. Now let us move to the next point. No, we have just studied only linear and reducible linear. Okay, and depend on the reducible linear, we have seen the substitution method also. Now we are going to see the exact differential equation, next method or next type of differential equation, ordinary differential equation. Okay. Okay, let us see. Exact differential equation, these are very easy examples. Only you have to remember the derivative and integration basic formulas. Okay. Exact differential equation is of the type m dx plus n dy is equal to 0, where m and n be the exact differential equation if where m and n are here, m and n are functions of x and y. These are not constants, these are functions of x and y, whatever it can be. It can be x square, sin x, cos x, anything. Okay. M dx, any equation of this type, m dx plus n dy is equal to 0, then such type of equation is said to be exact differential equation if dabba m by dabba y. Dabba means derivative of m with respect to y. In that case, m contains both the variable x and y. If we are taking derivative of n with respect to y, x should be treated as constant. That is a main difference between total derivative and partial derivative. This is a partial derivative, where with respect whatever the variable we are considering for taking the derivatives, apart from that variable, all the rest variables are treated as constant. Okay, and this equation can be said to be exact differential equation if del by m by del by y, if you calculate del by m by del by y, m derivative with respect to y, and del by n by del by x, n derivative with respect to x, and both should be same. Both should be same. If they are same, then such equation are called exact differential equation. If they are not same, means not equal, then this is called non-exact equations. Okay, now we are going to see some exact differential equation examples. Okay, and how to solve this equation. This is the formula for, like linear and Bernoulli equations, there is a particular formula for solving the exact differential equation. The solution is, as it is, take the integration on both sides. We get integration of m dx plus integration of this n dy is equal to, integration constant should be c. On RHS side, instead of 0, there is obviously integration constant c after taking the integration. But there is a change while taking integration of m with respect to x, y should be constant. This is a formula. You have to write this formula as it is in every example. Okay, y constant. Okay, and plus integration of n dy, we have to take those terms of n which terms are free from x. Okay, now what is the meaning of this term? Suppose okay, suppose these are three examples of terms or three expressions for n. This is my first example where n is this. This is second example where n is this. This is the third example where n is this. Now we have to see the meaning of terms free from x of n. Means what? There are three terms here. Okay, and this term contain x, this term doesn't contain x, this term contain again x. Means this is the only term in this example of n which is free from x. Therefore, in this particular integration, where if this is n and we have to take this n inside this integration, which is the terms of n which are free from x, there is only one term. That's why we have to take integration of y cube only. Okay, now in this particular example, which term contains terms free from x, means which term which doesn't contain x. This term contain x, this term contain x, this term contain x. That's why integration we have to take 0. Okay, there is no any term which is free from x. That's why in this particular example here integration contains only 0. Okay, now in this particular example, this term is a free from x term. This term is also free from x term, but this is not free from x term. That's why in this particular example, what should be taken inside the integration? 1 upon y square plus log y dy. Understood? The terms free from x means those terms of n we have to take inside this integration which doesn't contain x, means terms free from x. Okay, this is a formula. Now let us see some examples. Go on, write down. If you don't remember any formula, each and every time you have to recall that, then go on, write down all the formulae repeatedly, once or twice. You will automatically get mug up all the formulas. Okay, now let us see the examples. This is the first example. Example contains only solve this example. This is the term into dx plus this is the term of x and y into dy is equal to 0. Now comparing this example with this, we have this m dx plus n dy is equal to 0. Okay, now comparing this example with this, we get m is the coefficient of dx. Okay, Okay, m is coefficient of dx and n is coefficient of dy, including this plus minus whatever sign present there. Okay, therefore m is this bracket x square minus 4xy plus 2y square, and n is this bracket y square minus 4xy minus 2x square. And here is plus only, that's why n is only this bracket. Now next step will be you have to check whether the given differential equation is exact or not. Means you have to check this first condition. For that we have to take derivative of m with respect to y and derivative of n with respect to x and check whether these two are same or not. Okay. Now da by m by da by y, in that case x should be constant. M derivative with respect to y. This is x and x should be constant. That's why its derivative is 0. It contains minus 4xy. Only y derivative should be taken. Y derivative is 1. That's why minus 4x is constant. And minus 2 as it is, y square derivative is 2y. 2 to the 4y. This is da by m by da by y. M derivative with respect to y, treating x as constant. Okay. Now again, same way, da by n by da by x means derivative of n with respect to x, while that y should be constant. Here y is constant, that's why y square derivative is 0. Here y is constant, minus 4y again constant as it is, x derivative is 1. Answer is minus 4y minus x square derivative is 2x, 2 to the 4x. Okay. If you observe these two are same. That's why da by m by da by y is equal to da by n by da by x. Now what is the conclusion? You have to make this statement. Given equation is exact differential equation. Okay. Now once we decide or once we found that this example is exact differential equation, then we know the solution is this formula. Write down as it is formula. Everywhere you have to write down this formula. Okay. Solution is integration of m dx plus integration of n dy, where y is constant here and here terms free from x. 4 words should be written here. Now put this value of m is this as it is, y constant, and you have to take n, those terms of n which are free from x. N terms have total 3 terms, and this term contain x, this term contain x. That's why we have to exclude these terms. Only this term contain this is a free from x term. That's why we have to take only y square here. Plus minus whatever sign is there, it is y square here. Dy is equal to 0. Now make the integration. X square derivative with respect to dx is x cube by 3 minus y is constant, that's why minus 4y take outside, x derivative is x square by 2 minus again 2y square constant, integration of 1 is x. Okay, plus again y square derivative integration is y cube by 3. Now 2 to the 4, simplify this is our answer. Okay, these are very easy examples. Now let us see next. Solve y into bracket 1 plus x plus cos y dx plus x plus log x minus x sin y dy is equal to 0. By comparing m dx plus n dy, m is this bracket. Okay, take this y inside so that we can easily calculate derivative. Y plus 1 upon x into y, that is y by x plus cos y. N is this term, x plus log x minus x sin y. Now take derivative of m with respect to y. We get da by m by da by y is equal to y derivative is 1. Y derivative is again 1 by x is a constant with respect to y. That's why it becomes 1 upon x minus cos y derivative is minus sin y. Okay. Now again n derivative with respect to x. X derivative is 1. Log x derivative is 1 by x minus x derivative is 1. Sin y is a constant. That's why it becomes only minus sin y. If you observe these two are same. That's why da by m by da by y is equal to da by n by da by x, which is exact differential equation. And once we know this is exact, we have the solution formula. Integration of m dx plus integration of n dy, where terms free from x here and here y constant. Put this value of m here as it is. This is m dx, y constant, plus we have to take those terms of n which are free from x. There is no any term which contain only y. Free from x term means only contain y. There is no any term. Every term contain x. That's why you have to take only 0. No terms means 0. 0 dy is equal to RHS side is C. Now again integration y constant hai, and that's why y as it is taken outside the integration of 1 becomes x. Plus again y constant, integration of 1 by x is log x. y constant, that's why cos y outside. Integration of 1 is x is equal to c. Okay, that's why solution is this. Now let us see more to the next one. Is homework for you. This is homework. X square plus y square minus a square into x dx plus x square minus y square minus b square into y dy. Okay, see, this is the bracket. Outside the bracket x is there, that's why for taking you have to take x inside to this bracket. This is your also this y you have to take inside to the bracket. This is n. Okay, now solve this equation as it is by using above formula and all these things. Answer is this.